On the entity type, these associations are modeled or represented as navigation properties. Having seen the OData meta model, let's look into the system for an existing OData service to understand the OData service structure. Uh, to do that, we will go to a transaction called SEGW, which is SAP NetWeaver Gateway Service Builder. Um, it's a completely new design time transaction, which provides developers with an easy to use set of tools for creating the services, and it assists them throughout the development lifecycle of a service. In this one transaction, SAP NetWeaver Gateway Service Builder caters for the needs of both experienced and less experienced developers who want to expose data for using for easy consumption using a variety of platforms, frameworks, and devices. Um, while experienced developers have maximum flexibility to define a new service from scratch and integrate their own service code or other source code, the less experienced developer can reduce the time and effort involved in creating the service by importing these existing definitions. This is the service that I've already created, which is for the flight demo that we saw a while back, um, which contains the three entities, the flight carrier, flight connections, and flight schedules. Um, it has its own properties. So if you look at the flight carrier, it has four properties. One of them is the key property. It has some core EDM string or core EDM data types, and they are tied to the ABAP data fields. In this case, it is SCAR ID. Um, it has some navigation properties as well. One of them is connections. Um, Similarly, for other entities like flight connection, it has its own set of properties with carrier ID and connection ID as keys, again tied up to the ABAP fields. And again, it will have navigation properties as well. And then the flight schedule, which has various other properties and defined key. We have also modeled a complex type called seat availability, which is mapped to an ABAP structure type. And if you look at the properties, it contains two fields. We just collapse the entity type. For each of the entity type, we have a corresponding entity set, which represents the collection of the entity type. Every instance of the entity set will have the same entity type. We have associations, the two associations that we have modeled, which you can actually see as navigation properties here. Uh, these are the two navigation properties which are also represented here as associations: flight carrier to flight connections, and flight connections to flight schedule. So you can look at the cardinality 1:n that we have defined, and the source and the target entity as well. Besides that, we have function import, which is an operation on flight schedule entity, and the return type is a complex type, which is check seat availability, which we have defined here. Let me now show you the service document and the service metadata for the service that I've created. So this is the URI, which is the service route URI. This is the external name of the service, which will be accessible and known to the consumer. Um, it has three entity sets: the flight connection set, the flight schedule set, and the flight carrier set. Let's quickly look at the metadata by adding the metadata parameter to the service route URI. Again, the three entity sets with the key definition, and the rest of the properties defined with various type definitions. The complex type, which we saw earlier, seat availability with two properties, then the associations, and finally the function import. Uh, this is the entity container which contains the three entity sets. Now let's quickly understand the OData URI convention and look at some of the examples. So a OData URI would normally contain three parts to it. One is the service route URI, which represents the service itself. Then there will be a resource path, which defines what resource we are trying to access, and then the query option. So if we look at some of the OData URI examples, we already have seen the service route URI and the metadata. Um, Let me try and send an HTTP GET request with the service route URI appended by the flight carrier set entity type, and I've just given the format as JSON. So if you look at it, I get all the flight carriers as a result set. So it has a metadata, all right. But then the important part that I'm trying to focus here on is the flight carrier set, which is accessed through this URI. It contains all the flight carriers in the system. So it has, let's say, for example, carrier with ID AA, which is American Airlines. Then it has carrier ID AB, which is Air Berlin and Air Canada, and so on and so forth. So all the flight carrier sets are available here. I could also um, try and uh, find all the flight schedules, for example, which are entered in the system. So this is the list of flight schedules that are available in the system. So for a connection ID 0017 for carrier Air America, on the flight date, what is the maximum seat capacity and how much is occupied in various segments is what you can see. So it's a huge list of data that you can see. Okay. Moving ahead, you can also create a URI uh, which requests for a specific entity based on the key field. So in this case, I'm looking for the flight carrier Lufthansa, which is represented by the ID LH. And when I do that, I get the data only for the Lufthansa Airlines. I can also append the property on this URI to just fetch the uh, specific property for that entity that I'm looking at. Yeah, so in this case, Lufthansa is the carrier name. We can also navigate to other entities pending the navigation property. So in this case, let me just append the navigation property connections. So if you look back at our data model, the entity type flight carrier has the navigation property called connections. And if you want to look at what connections is going to take us to, it is mapped to a relationship called flight carrier to flight connections, which is, if we look at the association, it is this one, which originates from flight carrier and goes to the flight connections. So what I'm trying to do here is for Lufthansa, I need to know what are the air connections available or flight connections available, and gives me a list of it. So for example, there is a connection uh, from New York to Frankfurt. There's a connection from Frankfurt to New York, and Berlin to Frankfurt. So there are various connections which are available, and it describes me all of that. We can also add the dollar links parameter to the URI, which will return us the relationship itself, like in this case. So it returns all the URLs for the relationship instead of the actual entity. You can also find the number of records that are returned by adding dollar count. In this case, there were 5 connections which was returned. We created function import or operation on the flight schedule, which checks for the seat availability. So you can do that by appending the operation name after the root URI, and then passing on the various import parameters that it looks for. And if I just trigger one of them, I can see it gives me the list of seats, number of seats available, and a flag which says whether the seat is available or not. You have a query parameter, expand, that you can use. So let me just. So after the root service root URI, you define the entity type, and you define the expand. Use the parameter $expand, and then define the navigation property that you are looking for. What it does is not just give the target entity, but it embeds the information from the target entity into the source. So you can look here as part of the result or response. What we are getting here is the CAR ID, CAR name information coming from the flight carrier set, and for that flight carrier set, it tells you what are the resources which are available. So that gets embedded within the response. Finally, the $select parameter. This tells you to restrict the properties to, let's say, char name in this case. So it just gives me the char name and not the rest of the fields. With this, we come to the closure of this segment. In the next blog, we will start creating our first OData service. Thank you.